نرحب فيكم هون في فرع دمشق لنقابة المهندسين. وشركة طبعا أول شيء وجه التحية لمجلس الفرع على رأسهم طبعا الأستاذ المهندس محمد أيمن الحافظ رئيس الفرع، وطبعا الأستاذ رئيس الطويل كمان والحازم وكل أعضاء مجلس الفرع على جهودهم دائما الموجودة في موضوع دائما شو في حديث وتطوير وأمور علمية بتهم الزملاء. نحن اليوم عم نستضيف عنا شركة دايكن. شركة دايكن طبعا هي تكييف معروفة بتوقع عبر يعني قرون ما مو جديدة. طبعا هي شركة يابانية مشهورة بإنتاجها بتكييف كان بسبليت أو بي ار بي. طبعا هي قابل فرانشايز لها بالبي ار بي هي اللي كانت سباقه بهالموضوع. طبعا نحن بنرحب في عنا المهندس سامر مراد هو المدير الاقليمي لشركه دايكن. جاي اليوم جاي معنا المهندس أوتيل. طبعا هو الاستاذ أوتيل هو كمان مدير الاستشارات الهندسيه في شركه دايكن. اليوم عندنا يعني محاضرة لطيفة علمية. طبعا نحن حاولنا نضغطها قدر الإمكان. نحن إذا بدنا نعطيها ناخذ كذا يوم كانت، حاولنا نضغطها قدر الإمكان لأنه نضل الساعة 4 نقدر نكفي فيها نغطي الجوانب التطبيقية والعملية بهالمحاضرة. اليوم راح نحكي عن التهوية والتكييف في المباني السكنية وأنظمة التحكم. طبعا موضوع مهم، كل زملائنا المهندسين ميكانيك حتى المهندسين الكهرباء اللي هن عندهم أنظمة التحكم يهتموا بهيك موضوع هام، وإن شاء الله يكون في فائدة على الجميع. طبعا نحن اتفقنا اتفقنا طبعا مع شركة دايكن إنه بدنا نعمل عدة محاضرات. يعني هي الدورة حتكون متتابعة كل مرة بموضوع. فكل شهر ان شاء الله حنعمل نحن محاضره قيمه مختصه بموضوع معين بمواضيع التكييف. في الزملاء اللي حيضلوا موجودين معنا لاخر هذه المحاضرات حنمنحهم طبعا شهاده من شركه دايكن حضور دوره تدريبيه، طبعا بالاضافه بالتوقيع مع نقابه المهندسين مع توقيع الاستاذ أيمن طبعا. فاكيد هي يعني الى يعني آلة بال وقيمه مضافه للزملاء انه استفادوا من ناحيه الخبره واستفادوا من ناحيه المعلومات اللي اخذوها، واخر شيء اتفقنا الشهاده اللي حتكون يعني قيمه مضافه للعمل.
Today we will talk about residential. So as we have started this series, first we talked about air conditioning in general and how to rebuild in the proper way, because this is the opportunity for next 20-30 years how we build. So it is very important that we do the right thing so that the country benefits in the longer term. So Daikin is always there to support the right things at the beginning of the design. We are not there to sell. We are there full time, right from the concept that you are designing to installation, also service, because air conditioning needs service. So full 360 view is what we take. So I come from the pre-sales business where we support the consultants and owners to do the right design and other things.
بما أن المحاضرة تتم اللي صار قبل كانت هي عامة عن التكييف كلياته. اليوم حنكون في تفاصيل أكثر. أستاذ سامر المسؤول الإقليمي دايكن، وأستاذ أوتيل هو قبل مبيعات التكنيكال سبورت أو الهندسي، الطرف الهندسي تبع التكييف. فكل شيء حتى حين حكى هو من الطرف الهندسي أكثر حتى نقدر نفهم الشيء. مو ضروري عن المبيع أو يكون متعلق إنه نحن بس عم نبيعه، لازم يكون تقنيا يكون متطابق مع المواصفات اللي أخذناها.
So I'll ask my colleague Samir to.
السلام عليكم جميعا، صباح الخير. شكركم دكتور الكريم. طبعا مثل ما تفضل الدكتور عبد الرحيم، دايكن عاملين على إجراء عدد من الدورات لرفد المهندسين السوريين بالخبرات العالمية ونقل المعرفة والتكنولوجيا. وهي المرحلة الثانية خلينا نقول من الدورات، نحن عملنا أكثر من 12 دورة مقترحة من ضمن المراكز، من ضمن تبريد مراكز البيانات، التبريد المناطقي، التبريد الصناعي لمعامل الأغذية. في عدة حلقات بهالأمور هي بخبراء متعددين من شركة دايكن. حقيقة نحن الأستاذ الدكتور هو شخصية مهمة عندنا موجودة بدايكن ميداليست، هو مدير الاستشارات الهندسية للمجموعة كاملة لدايكن ميداليست، يعني عم نحكي على كل المناطق اللي هي من المغرب، من جنوب أفريقيا، انتهاء من تركيا. فإن شاء الله بتكون محاضرة جيدة لطيفة، وأي استفسار موجود نحن حاضرين نجاوبكم لنوضح لكم أي موضوع. هدفنا نحن مو تجاري، يعني ما حيكون اليوم الموضوع عبارة عن خلينا نقول أسعار أو أي أمور متعلقة بالأمور التجارية. شقنا هو شق علمي فني مهني لتبادل الأفكار، نتعلم ممكن عن السوق السوري، عن المشاكل اللي موجودة في السوق السوري. نحن كمصنع لأجهزة التكييف العالمية، طبعا دايكن الشركة مؤسسة ب 1924، صار لها أكثر من 102 سنة يعني بهذا المجال. فنحن أكيد بهمنا نعرف احتياجات السوق المحلي حتى نطور أجهزة تلبي هي الاحتياجات وتكون مناسبة للأجواء السورية. شكرا لكم، إن شاء الله نهار مثمر وبالتوفيق.
Thank you, sir. So basically, we will talk today about residential solutions. And Daikin, as a company, was formed in Japan for residential solutions. So our big business is definitely on the DX side, which is the split unit, ducted, and other cassette, that sort of things that you need. And then when you have more than one unit, you have VRV, definitely residential, commercial, and then chillers, airside equipment, so air handling unit, fan coil unit, all those sort of big chillers. Nowadays, data center also is a big thing. So this series today we are talking about residential, but in future, we will talk about all the different aspects of business that because there is a disconnect. The world is moving very fast. With introduction of technology, the technology is also changing at a rapid pace as well. Also about refrigeration. So one of the other things is as the country and the economy grows, food storage and food wastage also becomes important. So how we look at refrigeration also. So this is also we will do it. We have got fantastic team in refrigeration, right from big size ammonia plants to small cold rooms or anything. So this is something that is also important. So we should look at full heating, ventilation, air conditioning, and refrigeration. And all this, as correctly said, right now we are not 30 years back or 20 years back where you have no controls, just a thermostat is enough. Nowadays, air conditioning can be more powerful with controls. So as mechanical engineers, we should now also have the knowledge of controls, of how the system should work better. We all have smartphones and everybody wants to control from it. When they reach home, the place should be air conditioned, or the vice versa. They want to switch off some of the units. So these things are important. So let's not keep air conditioning as pure mechanical, but the scope is now extended. So today we will talk about that as well. So Daikin's core business, 91%, we do air conditioning, and then we do little refrigerants. So we make our own refrigerant and discovery on the refrigerant also, because the refrigerant for tomorrow is changing, the world climate. So now we are talking about air conditioning system controls. Now third things which has come very big is sustainability, or how the climate is changing. We are seeing more hot or more cold. The weather, we don't have the same weather like 15-20 years back. We have set seasons, and you can predict this month this is going to be the temperature. Now it is changing a lot. So this one is now driving, the world is warming up. So air conditioning is, blamed for the temperature rise or ozone layer depletion. There are various agreements on Kigali, and everyone has signed up. Fortunately, we have little bit of time till 2032 in our area to change the refrigerant. Europe and US and Japan, everyone has moved to the next generation of refrigerant. So we need to look at the refrigerant also very, very carefully, and what are the new refrigerants, because handling R22 to R410A to R32 or R134A HFOs requires different training, This is something also we will do it, because technicians who handle the refrigerant, they also should have the right amount, Designing is one, but how to deliver it is also important. So we work with UNEP and other organizations also to help in that. And this is what, as Daikin we do that, and this is our head office for R&D. This is in Osaka, it's Technology and Innovation Center. It's a LEED Platinum building, and there are more than 700 engineers work just to do research and development, to come up with the new products. So this is also important, that we come up with something new that will solve the problems. And we do a lot of collaboration with university, with different universities around the world. It would be our pleasure also if we have to, like locally, if we can do some collaboration and have something that we can support the training of the local engineers who are new to the industry, some research in terms of what are the best products, in our dry and arid climate. So this is something that we support and we work. We normally do a center of excellence which helps in building the skills for the future. So not only air conditioning business, but the full thing, as we say, is what is important for us to deliver, to the society. Society is what we believe that we need to, provide the right service. So this is part of one of the things that we thank you, for the engineering guild to give us this opportunity, and all of you came. So we hope we do a justice to your time and you get some good knowledge.
طيب احنا طبعا المهندس أوتيل جوشي هو باللغه الانجليزيه الحديثه، ومعنا المهندس نطيع حمود. فاذا في اي استفسار معلش احنا هلا عم نحكي ان جنرال، يعني عم ندخل في التفاصيل، فممكن هو يساعد الترجمه مشان اذا في اي امر معلش يسالوا الزملاء، ما حدا يكون اذا شغله يعني تمرق عليه ما يعرفها. مو غلط يعني، فحنحاول نحن نقارب يعني الامور المهمه يصير ترجمه لها باللغه العربيه مشان نقدر نوصل المعلومه بشكل كامل، بس هو طبعا هي المحاضره باللغه الانجليزيه للاستاذ. تفضل.
أول شيء إنه منشأ الشركة هو ياباني، وبلشت أول شيء حل مشاكل السكنية، بلشوا بالدك سبليت ما بلش، بعدين بلشوا يطوروا تفاصيل تعمل البي ار بي، تطور إلى آخره، بعدين عملت شغل. شغل الشركة هو تقريبا 90% 91.2% يعتمد على التكييف، هي شركة متخصصة بالتكييف مع دايكن. بعدين تطوروا لحتى يصيروا بالتبريد، حتى صار عندهم تخصص كمان كامل بالتبريدات، طبعا كله تحت التكييف، تبريد البرادات حتى ما يفسد، حتى نحافظ على الاكل بالرطوبه والحراره، وبس انه فتحنا براد حتى ناكلها. الشغله الثانيه الشركه المنشا الهيد كوارتر تبعه الطائر التصوير هو الابحاث باوساكا تبع الابحاث، ومساحته مثل ما مكتوب هون. هو كمان طبعا صديق للبيئه 100%. وهم بادروا كثير بجامعات بالتعليم وبالتركيب وبتعليم كل المنظومات اللي هن بيقدموها. هي نجاحات.
700 مهندس بيشتغلوا بمجال التطوير والتحديث
له مركز كثير R&D Research and Development، هذا عنده بيشتغلوا مجال التطوير والتحديث سنويا، عندهم ابحاث كامله وبيشتغلوا بالجامعات عبر العالم.
والبحث العلمي.
والبحث العلمي، فإن دائما مو هدفهم بس البيع أو لا، دائما بيعملوا أب تو ديت، بيعملوا دائما ريسيرش اند ديفلوبمنت لكل شيء تطوير، ولا صاروا كانوا ما ضلوا سباقين في قطاع التكييف الماشيين فيه. تفضل.
Like, just give an example. With Totori University, we are looking at what is the new air conditioning for sub-Saharan Africa. You know, in arid area, what we can change. Should we use the normal unit or we should change the technology? So this is what this university and we are working in, coming up with new things. Same thing we can do with other universities.
بيعملوا ادابتيشن دائما، هن بيعملوا عندهم حسب البلد، يعني بيشوفوا كمان كيف الكلايمت، كيف المناخ، بيعملوا شيء خاص كمان، بيدرسوا وضع البلد حتى يطوروا عملهم يعني يتناسب مع الجو او الاجواء في هذه البلد.
So basically, what you see right now, sales. So me and Samir, we are just above the ground, but below us we have a lot of people that support. We have product engineers, we have customer service, finance, a lot of functions. More than 800 people are there in Daikin, Middle East and Africa, and this is what we try to support to the whole market. And we believe in local talent. So Samir was just introducing our new colleagues. We have hired someone locally. So this is what we believe. We believe in localization. So Engineer Omar has joined us locally to support the business. What Mr. Hamur is doing and to spread our name. Thank you for that, for all these years that you have done. Now today's topic, is about residential air conditioning, right? So when we talk about residential air conditioning, it is always about what we talk about is about the architects. The first house is designed by the architect, and architects' need is different than air conditioning people. What we think for them, we are the last priority. The looks is everything, right? What happens is we get the smallest space to keep our equipment. If you do not discuss this from the first time and get proper allocations, it's difficult. So that's where sometimes we work with architects for them to understand, that what is the right airflow. Or, first residential application generally starts with architects, and many times architects needs to understand that we need to give space, for the overall building to look good, be it a house or a building, that the space for HVAC is important. Second thing is noise, that where we place the unit also creates, like if you have a master bedroom and the outdoor unit is very close to it and the noise is very high of that, then it's a disturbance for the sleep. So this is also very, very important in terms of that. And the most important part is everybody likes big glass. They want to have glass like anything. If you have more glass on the west side, you are going to have highest load and your electricity bill is going to be the highest. Is it possible to reorient? Or if not possible, then the specification of the glass. So we need to look at the basics with architects is also very, very important. Equipment can deliver the efficiency, but if the design is looking at that point, then you get the best out of the equipment. The idea is to have the less amount of tonnage, not the biggest unit. So if we can first look at and discuss with architects. So nowadays the concept is that whenever you do a project design, all the disciplines, be it not only architecture, structural, electrical, mechanical, all the teams sit together, even service, people who are going to look after it. Is it can they service this unit or not, right? Can they service this building in the right way, in the safe way? So all this is important. Also the green areas, for anything, if you are developing a master community, how much green coverage you have, cycles, parking, walk area, all this is important to get the right ecosystem. And then the air conditioning in that particular unit can be the best. So always a project when it is started, all the different parts needs to collaborate to come up with, because this is one investment that is going to last for 20-30 years. And it's a big investment. So it has to be done with the proper planning in the right way.
طبعا هو عم يحكي عن شغله نحن دائما عم نقاتل عليها، وبتعرف الاستاذ ايمن الزملاء كلهم دائما لازم يكون مجتمعين العماري مع باقي المهندسين لما يصير ما يكون التصميم لحاله، المعماري عم يشتغل لحاله وبعدين نحن نشوف شو الحلول اللي اعطاها، لازم يجلس مع بعضهم الميكانيكي والكهرباء مع المعماري مع الصحي الى اخره مشان ياخذوا احسن الحلول حتى ما يصير حتى ضياعات بالتكييف، يعني حتى يشوفوا يحطوا الحلول المناسبه ويحطوا الاستطاعات المكافئه لهي، خاصه لما يكون في عندهم كثير بالتصاميم الواح زجاج، ففي كثير خاصه دول الخليج عندهم تصاميم كلها زجاجيه، فدائما يفضل الجلوس والمتابعه من الاول حتى يكون الحلول مناسبه للجميع. تفضل استاذ جوشي.
So and not only that, so this is one is new building, but what about existing buildings, right? Let's talk about this building, correct? We have air conditioning system that is installed maybe 15-20 years back, and the technology has changed so much that the power consumption can be reduced by half, right? So we should look at two things, not only the new building stock or what we are doing, but the existing building, how we can retrofit the building to the most energy efficient way, because everything we are not going to construct new, there are going to be remain as it is. So how we can insulate the building better, make the building airtight, because most of the time if you have fresh air and you are releasing a lot of air through the building, it is not airtight, you are losing air conditioning and the cost of air conditioning is going high, whereas it's not the fault of air conditioning. So this is also very, very important. Right now there is a concept that is going on, and this is called ESCO services, energy services company. So people are looking at a building and saying that what is your electricity consumption, what is your cost to run this building, let's say a hotel building, and how much it's running, and the bill is let's say 300,000. So the company will say, okay, you give this 300,000 for us for next 5 years, I will invest, I will put new equipment, and after 5 years whatever is the lower energy bill is yours. So they save 40 to 50% and make that up in the business. So this is a new business line right now, that people are looking at water, electricity and air conditioning on how to do it. We have done a lot of buildings where they have replaced chillers which are like 15-20 years old, and now they are saving more than 30%. So this is also important, that we don't just focus on new building, but we focus on the existing systems as well.
طبعا الاستاذ أوتيل عم يحكي كمان شغله مهمه كثير، نحن مو بس الفوكس تبعنا على الابنيه الحديثه ولكن الابنيه المقامه الموجوده. هلا كله عم انه في نظام تكييف صار له اكثر من 20 سنه، وضرب مثال ممكن هون نحن عندنا، فصار كل هلا الشركات صار هذا نوع من البزنس، انه هن عم مشان الكهرباء الالكتريسيتي غاليه كثير، فلما عم يعملوا تشينج عم يغيروا الاجهزه التجهيزات تبعتهم التجهيزات الحديثه، عم يصير في وفر، وهلا النظره كلها الوفر للكهرباء، الوفر للمياه، الوفر كله هذا، حتى العزل، موضوع العزل حكى عليه كثير كمان، كل هاي الامور هاي عم يصير فيها هدر، فصار هلا حتى الابنيه المقامه الموجوده، يعني مو بس النظره انه نحن عم نشتغل على الابنيه الحديثه، وحتى الابنيه الموجوده لازم يصير فيها اعاده تقييم، وعم يلاقوا انه في مربح مجدي انه لما يصير تغيير للتجهيزات كلها حيصير عنده وفر بكل هالامور اللي حكينا عليها هي. حكى مثال عن الشجرات قد ايه صار فيها وفر والى اخره. تفضل
استاذ عبد الرحيم، ممكن اطرح ملاحظه بس؟
تفضلي استاذ.
ممكن نسال الجميع اذا الكل بحاجه للترجمه، لانه هيك اذا كنا بدنا نحكي شوي ونترجم تصور يعني
والله انا اتمنى يعني هلا هو الكل اذا عنده. طيب احنا صارت معنا بالمحاضره السابقه صار جانا انه نحن مو كلنا عم نعرف انجليزي.
خلينا نسال.
هلا اذا بدكم نضل هو ماشي بالانجليزي واذا في شيء حدا استصعب عليه ساعتها بنسال ممكن شو بتحبوا لنشتغل. يعني انا سابقا صار هالموضوع هذا لما المحاضره الماضيه صار جانا شويه هيك ملاحظات انه نحن مو كلنا بنعرف انجليزي فعدنا ما صار عم نحاول نحن نعمل يعني توافق.
ممكن نعمل تصويت.
لا هلا هو مش فاهم استاذ منال التصويت بس يعني طيب نحن بنحكي يا استاذ منال نحن حنحاول يعني على السريع يعني نقدر نحكي الشيء اللي هو هلا بصراحه مو كل عنده قوه بالانجليزي. هلا خلينا نكمل يا استاذ عبد الرحيم.
المحاضره ملك المحاضر هو يتصرف زي ما بده.
So there are big companies in the world like Siemens, NG, these companies are looking at big. Dubai airport is not a very old airport, but it is being looked at on energy services. So like this is also very, very important that we look at the existing building also. So in residential, we generally do it only when the equipment is failing. But there is cost because now people are using it almost every time. So how we can do it? Maybe it's heating and cooling, like you have a boiler and you have something on the other side. So how to combine that? This is also important. So today's topic, what we will look at is what the end user is looking for in today's date throughout the world. What is the trend? And what is a good solution? How about the codes for different applicable codes of ASHRAE, LEED, the green certification. Also, separate focus on heating. What we can do if somebody just wants only heating, right? For heating solutions. And then the residential, which is mostly VRV and VX. Of course, chillers for big buildings, if you have apartment buildings, right? What to do on that. And last but not the least, controls. So this is what we will get today's focus on residential applications on this one. So basically, residential application is built in. It can be an individual apartment, just one home, house, villa, big palace. Basically buildings, which is more apartment buildings. Nowadays there is a concept of gated community, means you have a lot of villas, buildings, clubhouse, all the gym, other facilities. So big community development and definitely master plan. If you plan to have a new city, you will do all the services for that. So how different designs can work in this different applications. That is what we need to look at and find the right solution, because one solution may not work for every application. So as we say, air conditioning has changed a lot from window AC to split, ducted, VRV, VRV 4th, 5th generations, and so on. We are talking about VRV with carbon dioxide, CO2, natural refrigerant. So the things are changing faster. Earlier 20 years, then it became 10 years. Now we are talking about every 7 years. The technology is changing. The speed is getting faster and faster of the change. So knowledge also we need to update in a faster way. So basically, the end user is looking for not only temperature, humidity, low bill, looking good, noise should be less. After COVID, air should be healthy. Is it a green technology? Can it last for 15 years? Can I install it in 2 days, 5 days, faster installation and controls. This is what the end user of today is looking. And this is what we need to satisfy. So basically, if we categorize it, it is comfort, energy efficiency, elegance, reliability, environment friendly, and definitely money saving things. This is what we have to deliver as an air conditioning professional. So comfort is very different. Somebody say 22, somebody say 24, somebody say 16, right? It's individual. So when we say it is a position where I can sit for 5 hours neutral, without feeling hot or cold, it's a neutral condition. So it depends on not only temperature, humidity, RH, how the air is coming, like air is falling directly on me, I cannot sit longer. So air distribution, if the cooling capacity, if it is too big or too small, that also affects, and how the air is filtered, the smell from the kitchen, is it traveling to the house or not, and how the air in individual area is moving. So comfort is defined by this 5 parameters. It is not just I give 23 degrees and it's comfortable. We need to look at all these parameters as mechanical engineers when we are designing air conditioning system. How much fresh air I can bring in, how much air I can recirculate, how I can put the controls, where I install the thermostat. All this I do correctly, but I put the thermostat under the supply air. It's not going to give me, the right condition. So placing of the thermostats also very, very important. And the air tightness of the building, the insulation. So all these parameters is what defines the comfort. So we need to look at all of these parameters when we design the system on that. So this is first and foremost, because this is the most important thing. When we do air conditioning, it is for comfort. And comfort is 4 parameters. So look at temperature, humidity, how you are moving the air, where the thermostat is kept, and the filtration. Right? This is what is important.
نحكي استاذ عن موضوع انه التكييف هو individual، يعني هو نحن درجات الحراره بتختلف من شخص لشخص، هي فرديه، ولكن بشكل عام نحن عندنا البارامترات دول لازم ياخذوا بعين الاعتبار عن كل مهندس ميكانيك لما بيشتغل للصالح. بيهمه دائما مشان يصير في كومفورتبل، يكون عنده هالراحه، لازم يكون عنده تحكم بدرجه الحراره، عنده الرطوبه، عنده بحركه الهواء، عنده هاي كميه التكييف كافي، وعنده اهم شيء الفلتره اللي هو مشان روائح. وبالاضافه للعزل اللي حكى عليه بشكل كبير، دائما هذا لازم يكون موجود حتى ما يصير في ضياعات. فبالتالي دائما الفوكس بالنسبه للمهندس الميكانيك على البارامترات هي يكون مفوكس عليها، يعمل فيها تحكم كامل حتى يوصل لمرحله الراحه المطلوبه عند الكاستمر. الكاستمر بالسلايد اللي قبله حكى شو هو هدف الكاستمر، شو لازم يحصل اخر شيء، يحصل على هالامور، بده يسيف ماني، بده راحه، بده انفيرمنت، يكون في بيئه نظيفه، ما يصير فيها اي تلوث الى اخره. فهي دائما نظره المهندس الميكانيك لما بده يشتغل بعمليه تصميم.
Now, second thing is, once I have comfortable condition, how can I make it energy efficient? So this is where the equipment manufacture, equipment selection comes into picture. What technology of equipment should I buy, right? So what we look at is, should I look at that it is giving me the best efficiency at one point, or I'm going to use it for the whole year, right? The air conditioning. So more and more nowadays, seasonal efficiency is important. We don't look at only one point, like 35 degrees. the efficiency is defined at 35 degrees has one meaning, but the seasonal efficiency is important. And how this one can be achieved, as we say, is first is the building. If I want to improve this particular building, I first install insulation on the walls or the roof, right? And if I keep the same air conditioning system, my bill can go down. If I make it airtight, I reduce the loss by 10%, my electricity bill goes down. So first and foremost is the building envelope. Second is definitely, can I put some more insulated glass, insulated walls, and then equipment that is good, having seasonal efficiencies throughout the world. Technologies like inverter, not a fixed speed compressor. Fixed speed compressor goes 0-100, 0-100. So if you go with variable speed drives, variable speed compressor, inverter compressor, definitely you save more than 40 to 50%. So this is something good. Can we change the refrigerant? Because refrigerant also can reduce the power. So low GWP refrigerant is something that is also important. And everything you do, but you don't do a good maintenance. You don't clean the outdoor units because we are in dusty environment. So if the maintenance is not done in the right way, you will not achieve the energy efficiency. So energy efficiency is not just selecting the best equipment. You have to look at how the building is treated, how the system is selected. Means you have selected inverter, you have selected good refrigerant, and you are doing a good maintenance. If you do this, definitely you deliver a good energy efficiency. Design, we do it, but it has to be delivered also. So this is also very, very important on that.
كمان الكفاءات صارت ما بتنحسب انه على مثلا شهر او اسبوع او ايام، صارت تنحسب كفاءة موسمية اللي هي السي سي اس بي خلال السنة كلياتها. فهو الكفاءة ما لازم تكون بس لفصل معين. هذا الشيء بيعطينا مردود احسن. مثل ما قال انه اليوم الكمبرسورات والضواغط ما لازم تكون بس تشتغل 0-100 عم تطور هلا صار في الانفرتر الى اخره هدول التفاصيل كلياتها. هذا الشيء تحسن تقريبا من 40 ل 50% من الاداء طبعا. ولكن مو بس هذا الشيء بيعتمد انه نحن ممكن يتقدم مكيف يكيف اوبن سبيس او مجال مفتوح. هذا مو شيء بالبنايات. نحن المفروض تكون البنايات مغلقه تمام حتى يصير في عندنا عزل حراري صحيح، حتى يكون في بعدين لقدام مردود احسن. وكمان اهم شيء صيانه المكانات. يعني اليوم اذا مثلا ابسط فكره اذا الفلتر مسطن اكيد ما حتعطي المكنه اداء، وتكون المكنه عم تنجهد اكثر شيء ممكن حتى تعطي الكفاءه اللي هي لازم تعطيها بس ما بتقدر تعطيها. هي بس اذا فكره تنظيف الفلتر، فما بالكم اذا نحن بدنا نعتمد على انه الصيانه تكون دائمه.
ولا بياخذ مثلا انا اذا في عندي مبنى كامل في عده مثلا وحدات عم يغذي مثلا تعطلت احد شيء كيف بياثر على المبنى كله؟ يعني هل هذا بياخذ بعين الاعتبار وقت التخطيط؟
تمام، بيعتمد التخطيط. طبعا نرجع نسوي التخطيط هو بيعتمد حسب نوع التكييف اللي عم ينحط، اذا كان شو نوع، اذا كان شلر كان بي ار بي بيعتمد على بعضه، او هو لتكييف مثلا مساحات، اذا كان تطبيق مولات فهو نظام واحد كبير. ممكن يكون منفصل كزونات، ولكن اذا في قطعه بدها صار صيانه اكيد الزون حتطلع خارج النطاق، ولكن ممكن واحده تغطي شوي على الثانيه. بينما اذا كان مثل مبنى سكني يكون في ار بي او مثلا كذا داخليه خارجيه واحده، ممكن يكون في باك اب واحده تشيل عن الثانيه.
يعني قصدك احتياط، يعني انا دائما وقت بصمم دائما بيكون عندي احتياط.
مو دائما، حسب الموقع اللي عم تصمم. تمام 100%.
فهي استاذ فاضل يعني في اماكن مثل مشاركه او الى اخره اللي انت عم تفوز عليها ما لازم توقف عليها، دائما في ستاند باي بيكون عنده مشان الموضوع هذا. لكن في الاماكن اللي ممكن تتحمل شوي حوس يعني ممكن تغطي عليها قطعه ثانيه تقدر تغطي شوي حمل بمسمى يعني. وفي الاحوال بيقضي هو يعني دائما التطور الحديث عم تقدر تشغل هي حتى على مستوى مكان وحيز واحد، يعني قطعه خارجيه واحده بيربط لك جوا 30 40 غرفه، فممكن تتحكم فيها انك تقدر تصلح بغرفه وشغال الباقي يعني.
هذا السؤال يعني كثير مهم.
As we said, inverter is no-brainer. Nowadays, inverter is available everywhere. The cost is also come down drastically as compared to 10 years back. So choose inverter and you can generally, save 40 to 50% as compared to the normal one. The idea is that whenever you are designing, right, let's save 1 kilowatt or 2 kilowatt in every room. Let's say we are designing a building. So if we can save, and there are 5 rooms, if we save 1 kilowatt or 2 kilowatt in every room by changing the glass, the orientation, putting the shade, or generally making like better construction, if you save 1 or 2 kilowatts in every room, you are saving 5 to 6 kilowatts, of the system that you don't have to install extra. So this is number 1 point. Overall house, if it is not possible in every room, can I save 5%, 10% in doing the right amount of design? Once we do that, if you're designing a building, saving 5 to 10 per apartment can amount to 100 or 150 kilowatt per building. And if you look at the community, that's 1,000 to 1,500 kilowatts. And that means you may not need one more electrical transformer. You can reduce this infrastructure cost. So this is where it is important, right? If you look at the room level, house level, building level, and the community level, and you achieve energy efficiency throughout the one. This is good for the new build if you are making a master community. But again, retrofitting can be done in the same way. Second thing is nowadays air conditioning is just not what we can give. People have different interiors, different needs. So you can go not with wall unit, ducted unit with grills, without slot diffusers, lot of cassettes. Lot of different customers are asking different. Underfloor heating, like somebody does not want to see anything. So you need to look at it of different options. Do not just look at one option of either wall, ducted. You have n number of options. Even we can do air conditioning without the ceiling. You can put it unit in the wall and do the ducting and have a grill on the wall. So there are possibilities in air conditioning of achieving anything. So this is something that needs to be looked at also, is that it should look good, feel nice as well. And definitely somebody, air conditioning, as madam was asking, what happens if it breaks down. So the air conditioning has to be reliable. It has to work all the time, or at least it should have some backup facility built in that. So choose where a good R&D, good reliable company, First cost is not everything. If you buy the cheapest and it's going to break down in 3 years, 4 years time, it's not a wise investment. We have invested for 15, 20 years. So looking at reliability on air conditioning is one of the main things. If you have one car, it can break, you can rent it, but if your air conditioning breaks down, what you will do, correct? So you need to look at it on what is the right technology that we are using, how I can split it. Let's say it can happen, it's a mechanical part, but if I have 2-3 units, I can still survive, right? So planning for that also, reliability in the design is important. Choosing a good product, future, like it should last for 10-15 years. Parts should be available. And manufacturing, if they do it on their own and not a third party. And because if somebody else is manufacturing a compressor, let's say for a brand, and that compressor is not available after 5-7 years. So this is also something to look forward, that you choose something that is reliable and it has a life of 10 to 15 years. And one of the most important things which generally is avoided is looking at indoor air quality. how good is the quality of air is also important to look at. And when you have high-end buildings, right, or somebody who is saying that yes, I want to get the best performance, then looking at fresh air, treated fresh air with either fresh air handling unit, untreated fresh air also if the unit can handle. There are mechanisms like air purifiers, purification systems. There are filters like carbon activated filter, MERV filter rating to be higher. So right now we are just using a filter. What is the grade of the filter? If you change the grade to MERV 4, MERV 5, MERV 8, your filtration level becomes better and your air quality becomes better. So this is good. Nowadays there are a lot of sensors available online and everywhere. You can put a sensor and you know what is the quality of the air. So this is also important to look at. Many buildings, many hotels, there is a new standard called WELL, W-E-L-L. This one looks at what is the health of the building. So this is also, like international clients are looking for those sort of things, green and healthy buildings. So healthy building also now has an index, and many places it demonstrates that what is the air quality of the building. So this is also important, especially when we have kids, right? They will go to school, they will get sick, and we want them to be, best treated. So when they come home, if the air quality is better, if you clean the air. So this is why many house designs, especially people look at on air quality, is because of the kids, that they want to give them the best environment. Asthma and other things, is also getting triggered by air. So this is important that you look at air conditioning. Indoor air quality also is very important part in that particular activity.
مختصر الحديث الاستاذ لطفي عم يقول انه عالميا صار في ستاندرد جديد بيعتمد على مدى صحيه المبنى. نحن بالماضي كان عندنا شيء يسمى الجرين بيلدينج او الليد بيلدينج، يلي هي بتعتمد على الانرجي افشنسي، قديش هالمبنى فعاليته بتخفيض استهلاك الطاقه. هلا صار في كمان مقياس جديد اسمه ويل، WELL، يلي هو بيعتمد قديش هالمبنى صحي بالتصميم تبع التكييف فيه، يلي هو من ناحيه تنقيه الهواء، من ناحيه درجه الحراره، الكومفورت. فهي نقطه كمان مهمه، يعني هالمعلومه هي اذا بتتوسعوا فيها انتم شخصي تبحثوا عنها، يلي هي الويل، لانه هذا اكيد الستاندرد بده يتطبق بالمستقبل بمراحل اعاده الاعمار باذن الله بسوريا على المباني الحديثه، خاصه اليوم خلينا نقول التشين العالميه، يعني الاسماء الكبيره صارت تهتم بهذا الموضوع. يعني ما بس فكره انه نحن بدنا تكييف لهالاوتيل، لا، هذا التكييف بده يكون اخذ درجه من الاندكس اللي هو المقياس تبع مدى صحيه جوده التصميم تبع التكييف.
بالاضافه للاستدامه،
موضوع المدارس، كمان المدارس انترناشونال كمان مشان صحه الاطفال عم يدوروا على هذا الويل، عم يحطوه مشان جوده الهواء. برا كثير عندهم موضوع المدارس انه الاطفال بيهمهم يكونوا جوده الهواء عندهم ببيئه يعني صحيحه، فكمان كثير بالانترناشونال سكولز هذول شغالين فيها، يعني بالاضافه للفنادق حكى عليها الاستاذ، كمان الانترناشونال سكولز عندهم كثير المدارس الدوليه بيحطوا على هذا الموضوع، بيهمهم كثير جوده الهواء مشان اطفالهم.
كمان
هي الأبنية الخضراء طبعا هو هذا القديم.
الأبنية الخضراء كانت مختصة بمدى كفاءة المبنى لاستهلاك الطاقة. هي نقطة. هلا اليوم صار في معيار جديد، ستاندرد جديد اللي هو ويل، اللي هو مدى صحية المبنى، بمعنى قديش التصميم تبع نظام التكييف بيأمن هواء صحي للقاطنين بهالمبنى. طبعا ستاندرد
في عندهم ترموستات، في عندهم سنسر بيقيس فيه
CO2 سنسر مثلا بيتركب على المكنه، وتصل لدرجه معينه بيفتح الدامبر بفوت فريش اير، وطبعا هو ستاندرد في له قيم، وحسب القيم انت قديش بتحقق منها بيكون هالمبنى اما كواليفايد او لا ما بيكون كواليفايد عند الستاندرد هذا.
يعني انا اذا عندي تصميم مثلا قطع خارجيه وقطع فلازم دخل هواء فريش.
طبعا
كيف بقدر تحافظ بنفس الشيء على المقياسين اللي هي حفاظ على الطاقه؟ لانه اذا دخلت هواء فريش معناتها زاد عندي استهلاك.
صحيح. سؤالك جدا ممتاز. هلا عادة نحن هون بنستخدم قطعة يلي هي الفام. Do you have any photo for the van? So الفام عادة الهواء اللي بناخذه من المبنى ونطرحه للخارج الاكزوست، هذا بيكون هواء مبرد فعليا، لكن بيكون نسبة الكربون فيه عالية منه صحي، وبندخل هواء فريش اللي هو بيكون هواء منه معالج، بتكون درجة حرارته عالية. ففي عندنا جهاز بيكون فيه هيت ويل، هو بدون ما يمتزجوا الهواء بينقل الحراره من الهواء البارد يعطيها للهواء الداخلي السخن بدون ما يصير ميكسينج بيناتهم لهدول الهواء، فانت هون بتكوني عالجتي الهواء ودخلتي فريش اير بدون ما تخسري الطاقه، لان الطاقه اللي اعطيتيها الهواء المبرد جوا نقلتيها للهواء الفريش اللي عم يدخل منه معالج. بتشتغل على الحالتين ان كان بارد او ان كان سخن.
ما بصير مزج بيناتهم.
بدون ما يصير مزج بيناتهم طبعا. وهي القطعة موجودة عند دايكن، ممكن تربط، وحتى في قطعة ثانية مثلها بيكون فيها كويل، يعني حتى الهواء الداخل ممكن انت تبرديه او تدفيه. خلينا نكمل، تفضل.
So basically you can get qualified if you are a consulting engineer, like you can be a lead AP, so green certified, right? Like this well AP also is another certification that you can have, and this is like internationally is getting big more value. On the refrigerant side, so basically everyone now is looking for a green certification. The government is making laws and banning the refrigerant. Europe has banned R410A, which we use. We are in Article 5 country, so we can still keep on using it. We have to declare it by 2028. 2032, the replacement will start. So it's not far, 6-7 years. R410A replacement, the government will put a ban on importing it. So this is something that is coming for Article 5 countries. 2040, we will have no R410A. So we need to look at the refrigerant because this is the worldwide agreement on the whole things. Basically, the things is not only refrigerant, part load efficiency, that means inverterization, which is happening at a very good pace. All the manufacturers are selling inverters. VRVs and also replacing the old systems. So this is something will also be focus of everyone in the near future.
يعني الاستاذ اقبال عم يقول نحن كمهندسين وكدارسين لازم ناخذ بعين الاعتبار نظرة بعيدة المدى انه شو الانظمة الجديدة يلي بدها تدخل تستبدل الانظمة الموجودة اليوم بالسوق، خلينا نقول الانظمة القديمة. مثلا من ناحيه الريفرجرانت اليوم الاجهزه الموجوده ال 410 هذا خلال 6-7 سنين حينعمل له بان، فما حيصير في امبورتيشن له لهذا الريفرجرانت. اليوم في ريفرجرانت حديثه اللي هو R32، حتى في ريفرجرانت طبيعي اللي هو CO2، في البروبان، في امور ثانيه مختلفه. فهي النقطه الثانيه موضوع الانفرتر مثلا، اليوم مثلا في مثلا المكيفات اللي فيها انفرتر، في كومبرسورات منها انفرتر. هلا هي الفكره وين؟ انه لو اليوم هذا الجهاز رخيص مقارنه بالجهاز المتطور اللي بيخدمك لسنين ابعد، بس لكن انت بالمستقبل اذا بدك تبدل الريفرجرانت وصار في بان على الريفرجرانت ال 410 انت مضطر تبدل السيستم كامل. ممكن حتى الفريون ال 410 يصير سعره اغلى، ليش؟ لانه المعامل ما بتعود بتصنعه، لانه عالميا خلص صار في عليه بان، فكلها اسعاره بترتفع. يعني اليوم بالسوق مثلا اذا بتجيب كومبرسور نون انفرتر يمكن يكون سعره اعلى من الكومبرسور الانفرتر اللي هو فيه تكنولوجي اعلى. ليش؟ لانه المصانع كلياتها قللت انتاج النون انفرتر، فصار كميته قليله بالسوق، صار سعره اغلى، والماس برودكشن طبعا صار اعلى للانفرتر فصار سعره ارخص. فكمهندس دارس لازم يكون في عندنا نظره مستقبليه انه انا كيف بده يضل الجهاز عم يخدمني ل 10 سنين 15 سنه لقدام.
In China, and India, biggest manufacturers of R410A, is moving very rapidly to R32. So in few years, they will not make those refrigerant as well. This is another issue of R410A. This is the hazardous material. So if you have some cadmium, some materials which is not good for the earth in recycling. So there is a standard ROHS compliant. Saudi Arabia is the only one that has implemented in the Khalij, no one else. So once everyone says this, so it is like as an equipment manufacturer, I cannot use the bad material. So it is ROHS is the new standard. So there is a certificate which we have to produce called CB certificate. This is a safety certificate required for the unit. So in that, this is the new clause. Europe has closed it. Saudi is the first country to implement it.
هو يعني انه في هلا ما في غير السعوديه عم تقابل هذا ريكويرمنتس جديد بمعايير يعني مشان الصحه والتوفير وكل هالقصه هذه تبع مشان الورمينج جلوبال الحراره احتباس حراري تمام. بس السعوديه عم تطبق هي الاستندرات بالخليج مشان موضوع احتباس الحراري. هذا موضوع كثير حساس وعم يشغل فيه يعني بدول العالم مشان بقى عم يزيد هالموضوع. فالتكنولوجيا الحديثه اللي عم يحكي فيها الاستاذ أوتيل انه عم تاخذ بمنتجات طبعا دايكن انه موضوع الاحتباس الحراري بعين الاعتبار.
هلا ال ROHS هي تعتمد كمان على مكونات الجهاز. مكوناته انه ما لازم يكون فيه مكونات خطره على البيئه، مثلا الروديوم، مثلا مواد سامه، لانه هن بيوصلوا للمستقبل انه هذا الجهاز بده يعمل له ريسايكلينج، فممكن هذا الجهاز يضل موجود بالدوله خلينا نقول، وممكن هو يلوث البيئه بالمستقبل بهي الدوله. لذلك حتى الاجهزه الحديثه اللي بدها تجي المفروض تكون هي الاجهزه مو محتويه على المواد الخطره خلينا نقول. What's the provision for ROHS? Recycle or replacement? Restriction of hazard substance يعني منع المكونات الخطرة اللي هي المواد المعادن الخطيرة.
So there are metals that are classified as hazardous which cannot go in the landfill. It has to be recycled. So those metals are banned on that. So these are the main parameters. You know, healthy, environment friendly, reliability, and comfort, right? These are the main parameters for residential air conditioning. So once we have these parameters, right? And let's say I want to design a system. So what we look at also is how many people, what is the use of it, where I need to provide control. So means how many zones I need to create. If I create one thermostat, I cannot get control in every area. Then I need a VAV for each area. Or should I go for a separate indoor unit for each area? So we need to look at first where I will have the controls, how many zones I will divide this air conditioning system into, how I will distribute the air flow, indoor air control. Do I have a fresh air handling unit, a VAM, or a normal untreated fresh air, which will be treated by the indoor unit itself, or how I will put the controls, how I will put AI, nowadays we are talking about, or Internet of Things. Can I do scene together, like you have one area where you want to create the night scene where you want to see a television with a particular temperature, curtains off. So you can create a scene of different scenes, So this is also the controls possibility is there, and it can change the different temperatures with the different usage. So this is also an important aspect of design, what you want to design, and then definitely your global impact on environment means your GWP, your well standard, and other things. So this is what you look at, right? So let's look at very basic things. Once we, let's say we have 2 units only I need. I have one living area, one bedroom area. And what are the things that I will do? I will use it one at a time, either living or bedroom. So can I use this as a design part? That can I use a multi-system that not go for multiple areas of operation? Or do I need the unit in every room working all the time? So this is where you need to first identify how you are going to use it. And then you can select a system. There are multiple systems available. You can have 1-to-1, you can have multi, you can have mini, you can have VRV, you can have chiller, you can have n number of combination on that. So most simple application, right, is, let's say I am buying, I have an existing apartment, there is no air conditioning, heating or air conditioning. I will select a unit. So I will select a wall unit, right? This is the lowest of the system. And this is the first time it is used in various applications, and this is the standard AC. It can heat or cool, and it is the most cost-effective option. So this is great if you are doing one. If you have to do the whole house with 5 or 6 units, then the things change, right? So if it is one unit, definitely inverter. But in this one, why this is good is because you will have cost-effective solution. Go with inverter, so your electricity bill is less. If you can choose a better refrigerator, then this is also having in a good way. Installation is very fast, very easy, right? And it's available everywhere. It's not that you need a specialized company on this one. Only problem is if you have more than one unit, then you will have more number of units. So where to keep it? The electricity, how to connect it, And if you want to have a good interior, it will not look good. So this is where you need to look at it. Also, if you do long buildings, generally split units tend to have 15 meters height difference and 30 meters of total piping. So this could be a problem if the piping is long. But if it is for a normal use, it's not a big on that. Why we say inverter? So this is one example of the whole year that you have the air conditioning, heating or cooling need, and the outside temperature is changing, every day. So let's look at how many hours each temperature. So the graph here is showing you temperature. This is the temperature line. So this is the temperature, and this is number of hours. And this is what generally we use the air conditioning for, and this is the heating area, right? So what we are looking at, if the unit is saying that I have efficiency of 35 and it is doing good, if it is on-off type, then you have only one point to look at it. So, but the season is continuously changing. If you use inverter's efficiency as the temperature goes down increases, and the temperature is continuously changing, right? We are still using it with 30 degrees. So this is the power of inverter, and you will save a lot of money. Anything that works for more than 6 to 8 hours as a motor, if you go with an inverter motor, definitely it saves you money in that. Second is the multi example. So split is very, very normal, right? So now if you have 3-4 areas, should I go with 3 or 4 separate units? Or can I go with a multi sort of system where I can have multiple indoor units connected to a single outdoor unit, right? And this can run. So difference between multi and mini VRV is here you have piping for each unit separately. In VRV you have a single piping that branches out. So here what you can do is, if you are using 1 or 2 rooms during the day, 1 or 2 rooms at night, and you are not using all the units at the same time, then this makes good sense, and you will avoid large number of units, you can take some diversity. You may not be required, like if you want 3 kilowatt, 4 units, that means you install 12 kilowatts. If you go with multi, you might install 9 kilowatts. So you will save in that initial installation and the power that is connected to it. So this is also another way of looking at it. But there are limited capacities. So if the area is big and your load is more than 7-8 kilowatts, you have to go with VRV. Again, the piping limitation is generally the same, around 30 meters on that. Basically now, if we look at on the other side, that what is the standards that we need to look at. So this is general one, right? What are the exact standards that we need to follow? The world accepts different standards. ASHRAE is generally accepted in air conditioning as a fantastic standards, and they have got 3 important standards for us at this stage: 55, 62.1, and 90.1. So 55 is general comfort, how to achieve comfort on that. 62.1 is talking about ventilation, what sort of air and what is ventilation rates that is required for different application. And energy efficiency is covered under 90.1, right?
يعني نحن بالنسبة للسوق السورية حسب طلبات الأشري أهم 3 ستاندرات من الأشري إصدارات لازم ننتبه عليها هن 3. رقم 55 اللي هو بيتعلق بالراحة، قضية درجات الحرارة المناسبة، درجات الرطوبة، الأمور هي. وعندنا 62.1 هذا بيتعلق بالفنتيليشن وشروط التهوية للمبنى. والثالث اللي هو 90.1 اللي هو متعلق بالإنرجي إفشنسي. هالثلاث ستاندرات من الاشري، هالثلاث اصدارات هن اللي لازم يكون الفوكس عليهم للمهندس الدارس بحيث انه يكون متماشي معهم.
سوريا طبعا يعني سوريا.
ستاندرد 62 لازم يكون 2 واحد 62 واحد للمباني العامة، 62 2 للمباني السكنية.
So 62.1 is for the general building or commercial building. For residential
62.2. 62.2.
شكرا مهندس أمجد.
So I put it in the next one. Because these are generally acceptable standards. But as you correctly say, low-rise residential is 62.2. So which covers G+4 buildings and lower, 62.2 on that. And 92.2. So residential less than 3 stories there is another standard. So earlier 62.1 and 90.1 came in, and then everybody said that this is good for buildings and everything. Give us something specific for residential. So this is a substandard called 90.2 and 62.2 specific for residential applications. So G+3, so G+4 and above is covered in 90.1 and 62.1. So you might have still, let's say if you are doing a building, apartment building, right? You are still following G+3 only, but still you have corridors and other areas which is not covered in 62.2. This will covered in the 62.1 and 90.1. And thermal comfort, so basic comfort like clothing, and so it has gone very much into detail. The 55 gives you a very good idea on what exactly to do when we are designing the comfort on those levels. So basically, if we look at ASHRAE, 55 for arid climate, we are here comes under arid dry climate, and then the clothing style, is also different. So this one affects how we feel the air, also airspeed and temperature, and the mandatory design baseline. So design baseline, if you put it, and then how higher you can go to achieve that. So normal levels if you take it, and if you take the different activity levels. this defines what could be the comfort level also. And then it is measured by mean vote, how many people are happy, how many people are not happy. So predictive mean vote. So this is something that requires a little bit of acceptance. Many times we use HAP calculation. I think most of we are using HAP as the basis. It does a lot of job for you once you select those sort of things. In the end, you don't need to do now a lot of psychrometric calculation. It will do all your viewpoints and humidity and everything on that. But what you need to look at still is the ventilation strategy, because in the end, comfort in arid zone depends a lot on the ventilation strategy as well. So this is something that you need to be careful of, but good programs like HAP and other load calculations do take care of it. So this may not be too much of a focus of an engineer right now. It's good to know so that you have the right approach to design parameters, what you select in your HAP calculations. So basically 55's scope is less than 3 stories residential, and basically we should not look at just defaults. It is radiant heat, airspeed, humidity, clothing and activities. So these are the 5 main focus that is being looked at. Radiant heat is coming from the roof. Also, if it is a stone building, the building, a lot of buildings, what we see right now, right, has, this is the typical of this area is you have the stone that we use, and the reflection of that is different from a brick. So this is also important when the building is using the local materials, which has got a better quality of heat retention or rejection. And that gives you a better indoor air quality and the comfort also. So this is also important for your U value and the correct calculation. If you take the default values, you will not reflect this material, what you are using it. So this is where it is good. Sometimes natural ventilation or natural cooling, might be okay to do with it. You don't need a mechanical cooling. That means you can have openable doors, openable windows to achieve the required amount of cooling also in some of the seasons. So you need to consider both, not like in UAE, if we are doing the design, right, we will consider full year 24/7 air conditioned environment, which may not be the case in the other areas, because this is the high temperature zone. Where the weather is very, very lenient on very few days. So this is what is also very, very important to look at it on that particular thing. So this is the big change. If I come from somewhere else and do a design in Syria, it may not work because of these conditions. So second thing is the shading. So this is also looking at how nowadays a lot of solar panels we are using, right? It is good and bad. Right? Sometimes the temperature around below that is very high also, but it is providing you some sort of shade also on the roof. So those areas that require shades, that is an additional layer. But if it is too low, if the walls are too high, then you are creating an envelope which is now generating heat, and it may be higher than the environment also. So shading and comfort also needs to be looked at in that way. Insulation, I'm sure nowadays insulated bricks are normally preferred for at least the outer walls, right, with the right U values. This can reduce. One example is when UAE started looking at it, they were at 140, 150 watts per square meter. By increasing the insulation on the bricks and the buildings, They are now at 90 watts per square meter. You know, they have reduced by 40% the heat load. The other thing which has gone wrong there is they like shiny buildings. UAE, you know, everybody looks glass. It has to look great. So your solar beam has increased a lot, which is good for Europe. They want to have more heat, not good for environment. Like you know, we need less amount of sun. So this is the trade-off. So many times you see the whole building, but back of it there will be actually a wall of pure concrete, you know, insulated wall. So this is also very important, is insulation. The idea is to reduce the load. The idea is not to sell bigger systems. The idea is to have minimum systems. So shade, insulation, and air movement. As we say, air movement is again another thing. As you are reducing the load, so this is the challenge which we face every time with VRV. The load is less. Now earlier everybody used to do it, and HAP does it. 1 ton is 400 CFM, you know, roughly that sort of value. Means your airflow coming is quite high, but your load is less, and then you will have air problem. So do not look at the values what you calculate of airflow. Look at how much is required. 7 or 8 times you want to move the air. You do not want to put too much of air. So load calculation sometimes misguide on indoor air, you know, on how we are moving the air also.
Is that right to use more than one design guide in the environment of this country?
أنا سمعني شيء.
Is it changing all the seasons? Is that right to take more than one design guide in a country that is changing?
So you take the worst point.
Because the climate is changing all the year.
Correct. So see, our climate, as you correctly said, is changing throughout the year, right?
Like
In a day also.
Europe now don't have air conditions. For
Yes.
example, in France.
They are suffering.
And the climate's now in 40 degrees and high temperature and high humidity. Yeah.
So that's where we have to look at it, the data. So there is ASHRAE has very good weather profile situations. So they give you last 15 years data, and then there is worst case 1%
What's
data.
what's the consideration of these design guides we have to take care of?
Correct. So unfortunately it is historical data. We don't have prediction, right? So we have to go for the worst case. In the break, I will take out the ASHRAE guide and I will show you. There are 3 points they look at. One is, generally everybody uses, is a normal occurrence for last 10 years, and this we use for design. And then there is very small percentage, but the temperature is higher. And if you worst condition, so that is the worst condition, because like 30 years back also the world has this problem. The temperature was on a different level, and then it settled down. So this is a good point of what is the design temperature for Syria. I think as all the design people, you have to come to a consensus. Otherwise there is a problem like in Egypt. Problem in Egypt is everybody is designing, one is designing at 40, he will design at 42, somebody else says, no, I am better than both, I will design at 43. But this is not good for the industry. So we have to come up with a single number. Maybe we work together and do it.
What's currently the design condition for Syria, for Damascus, let's say? What is the ambient condition? 40.
So -2 for heating and 40 for cooling, right? So this is where it is. Now somebody suddenly, like you have this issue, and to satisfy your client you say, I'll design at 42, right?
It's an application السوري للعزل كمان حاطين قيمة تصميمية لدرجات الحرارة الخارجية في المحافظات موجودة في المرشد.
Correct. But this has to be revised to 2026 also. Right? So this is something that also is important, because as a manufacturer I can give a design and performance, best performance to a temperature. If everybody changes, then performance you cannot check with 3 manufacturers, right? So that's where we have 3 main zones: T1, T3 and T4 zones. T1 is 35, there is 46, T3 and 48, which is Kuwait, for the higher T4. There is a talk that is going on based on Egypt case to have 41 degrees as a mild condition and achieve as T1.2. That is not final in Egypt. They are working on those conditions.
الحرارة الخارجية التصميمية بالنسبة للبيت أو الفيلا معنا مشكلة قدام إذا أنا بعمل تغيير لشي مواد غذائية. هون عندي التصميم أنا كله بيختلف جذريا، وهذا بسبب لي مشاكل كثير بعدين عن التصميم.
So the question is that we are designing the same for the refrigeration and for the air conditioning.
Basically, the outdoor unit, the condensing unit is the same. So the performance of the outdoor unit definitely is ambient condition, no matter it is human or food. It is the same. The problem comes is on how the indoor condition is maintained. One is where we need comfort. The food does not need comfort; it just needs temperature and humidity to a certain extent. So the design temperature should be the same on both the sides. So this is, as correctly said, if it is 2023 code, sorry, I was not aware on that. I thought it was a little bit older one. So if the temperature is designed as 40, and there is always, so 40 means whatever equipment is supplied will not trip at 43 or 45. So whatever as a manufacturer, we give an operating range. The equipment will work between this temperature to, let's say, 46. Means if anything goes wrong, we are liable, But if you put it in an area where continuously the temperature is 48, 50, it is not the outside temperature, but because of recirculation, poor installation, the temperature is rising, and compressor is failing or anything is failing, then the manufacturer cannot guarantee that because the installation failed. So general operating range, good news is around 46 degrees. So if you are designing at 40 degrees, and let's say after 3 years the temperature is continuously 42, 43, the equipment will still work, but not as efficient. It may, give you less comfort. Inverters will not consume more power at higher temperature, but it will give less cooling because it will go in protection mode. This is good and bad thing of inverter. Inverter cannot consume higher power, but it can reduce the capacity. Ashray, generally they do it around 4 years.
4 سنين. لا المهم الخلاصه اللي عم نحكي فيها الاستاذ اخي، نحن بنشوف في عندنا هيستوري، بنشوف عندنا شو هي درجات الاسوء شيء. ما تحاولوا تصمموا مثل برا عم اقول لك بمصر انه بيصمموا على 46 وعلى 30. احتمال نحن تجينا سنه يكون سيئه مثلا، ولكن انت مشان توفر ما تكبر حجم الاستطاعه عندك بالتكييف التجهيزات تبعك ولا تدفع مصاري اكثر، بجوز سنه تجي صعبه هي، ولكن انت تصميمك حاول تشوف شو هو الخطط الزمني لبلدك، شو هو درجات الحراره العاليه بشكل عام. فما تحاول انت تكبر، بصير في هدر كبرت استطاعتك، كبرت تمام يعني كل شيء دفعت مصاري وفي هدف فيها.
وهو الجهاز بيشتغل يعني
تمام وهو
بس هو الجهاز مصمم يشتغل لل 46
يشتغل تمام فهو بصير احتمال عامل لك ما بيعطيك الافشنسي الكامله يعني ما بيصير بس ما بيسقط الجهاز يعني ما بتوقف ولكن ما بيعطيك الفعاليه بعد 3 ايام اللي حكى لي الاستاذ محمود يعني هن بيجوا فما في داعي انه الواحد يعمل شطاره مثل ما قال الاستاذ انه مصر عم يعملوا شطاره
يعني.
ايوه انه يكبر وهي بيعملوها كثير عندنا حتى بالتدفئه بيجي لك معلم بيجي هو بيقول لك شو بدك بالهندسه بدك تدفع بيقدحوا زياده هذا بيطلع عنده تتحول عنده المرجل من كاتيجوري لكاتيجوري صار دفع اكثر صار دفع كذا مشان ما سوى عمليه حساب دقيقه. فهي الفكره كلها اللي عم نحكي فيها انه نحن عندنا شروط بسوريا معروفه بالاشغال معروف شو الاتجاهات تبعات درجات الحراره التصميميه فما واحد يبالغ وطبعا دائما بيرجع هو بعيد عن موضوع الانسوليشن العزل الاستاذ أوتيل كثير عم يحكي عن موضوع العزل الضيعه كثير مهمه موضوع العزل ومشان الضيعات مشان تحصل انت على شيء صحيح هذا الزبده تبع الحكي
استاذ بس في شيء كثير نقطه مهمه دائما بكل الدراسات بجميع التصاميم في شيء اسمه نظره مستقبليه للتوسع يعني دائما انت بحساباتك احيانا بنطلب نحط زياده استطاعه على امكانيه التوسع خصوصي مباني دوله مباني فنادق عندي مستشفيات في شيء اسمه عندي انا مستقبلي توسع يعني انا التوسع زادت عندي التكلفه تبعتي فهي احيانا بيكون في مقدار معين
فيوتشر فاكتور
هلا نحن بالفيوتشر كالكوليشن عاده المصمم الدارس بياخذ سيفتي فاكتور تقريبا 10% فهي بتساعده للمستقبل مثلا اذا هو ارتفعت درجات الحراره عنده فهو حيزيد اللود عنده فاوريدي اخذ بعين الاعتبار 10%. هلا باجهزه دايكن لا مو للتوسع لا ارتفاع درجات الحراره التوسع التوسع
مختلفة موضوع التوسع يا جماعة موضوع التوسع مختلف هون ما نحن يعني بده يكون عنده نظرة مستقبلية فهو اصلا المبنى مصمم خالص يعني اذا بده يزيده بده يزيد معناه نظام جديد يعني ما عاد يكفيه يعني انت ما عاد فيك تدفعي مصاري على نظرة ممكن تصير ممكن لا دائما هدفك انت اقتصادي يعني دائما بدك تحقق شغلتين بالتكييف عندك الراحة والاقتصاد الاثنين بدهم يكونوا متوافقين مع بعض ما انا كثير وهي اصلا عمل الهندسه يعني
ممكن نحن ما نستعملها كمان نكون دارسين نحط الرئيس للحافظ للدراسه دارسين على الاساس بنحط نكبر على الخارجيه تزيد خارجيه
بس مو بناء كامل يعني نحن نشغل بناء كامل نحط له تكاليف ما حيصير بعدين
السنه الجايه فانت اليوم ممكن تكون
تمام هي لا تحكي غير هلا اذا نظره مستقبليه غير اذا محطوطه ومخططه بلان كيف حتصير مراحل مراحل اذا في مراحل بياخذها اما والله نظره مستقبليه انا شو بدي ساير ممكن اتوسع وما لا ما عندي انا لسه ماني مؤسسها ما بدفع على تكاليف
بالدي ار في فلكسبيتي
طبعا ممكن في حاضر خارجيه
هتطلع تربط عليها خارجيه ثانيه
تمام موديول ثاني
تمام بصير بيحسن
Just one thing, that does not mean, so one thing always comes this, that should I use high ambient units in Syria, which is good. So like what will happen is that let's say you have a standard ambient unit, which is you're up to 46 degrees, 0 to 46. If you go for high ambient unit, which is up to 52 degrees, that means the design point is at 46. The design of that equipment. The other equipment is design point is 39. If you change this, suddenly you will have equipment that is higher power consumption and it will not give you higher capacity also because it is not optimized for it. So always select the right equipment that is for you. It is not like an insurance that if I'm buying a high ambient unit, it is good. If everybody does that, the country's power consumption will shot up by 20 to 30%. Right? So the other part is what we need to look for design watch list is the roof heat or the area that is coming from the west, the glazing on that side, and areas where air movement is not enough. You do your design check in that area, and then you get the better design. So look at, these are the three main areas: the roof, the glazing, and areas where air, the load is not much. That means you have very small airflow. The area in the middle has no glazing. It is surrounded by air conditioning, but the area is big and the airflow is very less. Right? So then there you need to make sure that the airflow is enough. Otherwise, so this is what Ashray 55 glide, if you have to think only three things, this is what it says in general. That do not look at everything which is glazing, because west glazing will give you very high airflow. The area which is not covered by any glass will give you very less airflow. So be careful on those airflow distribution. Roof, definitely, we all take good care of it. So if you get good PMW, means predictive mean work in that areas, your design would be perfect. So look at that particular thing in that particular line. Basically, now for we look at the ventilation, 62.2, right? So there is two parts. One is continuous ventilation and one is intermittent ventilation. So what you do when you have something, let's say a central unit which is continuously taking the exhaust out, or you are bringing the fresh air in, the rate can be less. But if you have intermittent, because it has to do work in a small period of time, then your air flow rate goes higher. But it is not working 24/7. So there is plus and minus of both of this. So if you do a whole one, if you want to maintain pressurization, so you don't want the dust or the foreign particles from outside to come inside the building, which is the right design, you need to go with pressurization, which is some amount of more fresh air than the ventilation, and then filtration, because when you are bringing the air from outside, the filtration also is important, and there it is PM 2.5, because the dust size, what you look at is PM 2.5. So PM 2.5 level control is important, and the fan pressure, because you need to maintain the right amount of pressurization things. Also, exhaust and air intake locations. So there is a full guide on 62.1, which is very good to use it anywhere. Like 6 meter distance between the exhaust and this one, or in the different faces of the building. So if you are taking it from west side, on the east side, you have exhaust and fresh air. This one provides you with a better, no recirculated air in that. So this is something that is also important, prevailing wind direction. So what direction the wind is for that particular project, and making sure that the air is not getting cross-contaminated when you are exhausting it. So air intake on the direction and exhaust in the leaving direction. This helps also to build the building in the proper way. So these are proper guidelines and proper checks. If you follow this, you get your best possible indoor air quality on the ventilation as well. So basically, if we talk about, we talked about this before, that we have 62.2 and 92.2, right? They have got residential values already built into that. Different between some calculation methods are there in terms of formulations between a single and the shared spaces. So that means you have a standalone unit and an apartment, right? Even if it is low rise, there is slight amount of difference in terms of calculation formulas are there. So if you are using it for a particular one, look at what one is used. Is it a shared space, means it is shared by many different users, or it's a single usage? That is the main thing on those two differentiations that you can look at it. Other than that, pretty much same on the other side, right? this is, as we say, predictive mean mode. So this is the in the end the judgment that the design is good or not. So if people are happy, most of the people are happy. There will be always few ones which will not be happy with what is there because of metabolic range, because of clothing, where they are located. So this can happen, but this is also good to get the feedback. So once the design is done, the satisfaction. So this is like a year check. After 1 year of installation, how is the satisfied user also on those ones. So this gives the next project, what you are going to design, to do any improvement. If you do not do a check, there is no improvement. What we cannot measure, we cannot improve. So this is also important that you measure your parameters. So this comes into commissioning. What we do for commissioning? We just switch on and adjust the airflow, or you look at proper airflow, indoor air quality, temperature in 2 different sets of temperatures, summer and winter, because we have both. It is not just the summer cooling, winter heating also. Right? So 2 sets of reading is taken and documented so that the performance is validated. So that next time when you do a design, this is the one that works on it. So this is where predictive mean mode is very, very important to do it after the completion as well. So basically, activity-wise, there is a table given. So you need to follow those parameters. In that, all those.
أنا سألته كيف يحسب الميتابوليك ريت حتى يتأكد من الديزاين، فعم بحكي له على الفورمولا شلون بتحسبه.
So basically, like normally we take domestic one relaxation formula. So in a house or in a residential application, it's not no work. It's relaxed one, right? So you look at that formula and you look at 1 to 1.3 time. So whatever is the seated at rest value times maximum 1.3 you can take. You should not take to a very high metabolic rate on those applications. Generally also number of people are less. So it's not really a big contributor for that. The feeling wise, like the end result, is the clothing. Because winter is different and summer is different. So this one also plays a role when you are looking at the verification of your design. So this is where the standards have gone up to that level to give you the satisfaction score also, and then you plot it on where you are, in this one, that how many users are happy, how many users are having issues, and what is the root cause of that. Is it airflow? Is it temperature? Is this? So this one provides you with a verification of your design also, which generally we may not do it. We commission it and we forget it. So airspeed is generally the skin, velocity on the skin. So if we have 2.5 meters per second, it's considered to be turbulent. So airflow 0.05 meters per second to 1.2 meters per second, in that range at a human level is important. On that is general air, but at a human level, 0.5 meters per second to 1.25 meters per second. 0.5 meters per second.
0.5 to 1.5
to 1.2.
1.25.
This is the maximum.
هذا الرينج لازم تكون سرعة تلامس الهواء مع الجلد أعلى من
1.2 من 0.5 ل 1.2.
هذا بيأثر علي باختيار القطعة الداخلية إذا كان
هذا بيأثر على الراحة، هذا بيأثر على
بس
الراحة.
أنا على اختيار القطعة الداخلية للمروحة الداخلية يعني على السرعة اللي بدها تكون فيها حسب إذا كان عندي مكان كبير فمعناتها أنا ممكن أحتاج تطوير لنفس المكان.
صحيح.
أيوة.
And when she select the speed, this is part of the design to do it. To meet this.
No, this is the final one. When you are looking at, this is the airflow distribution, not on the equipment. So this is when you do the duct design, the grill velocity. The grill velocity and the reach. So when you are looking at the grill velocity and let's say it is reaching at 4 meters. So at 4 meters, this should be the speed. So this is the end velocity of how much air you are going to have. So the grill, so this one depends on the grill velocity and the type. So sometimes, you know, we want to go for linear bar grills because it looks good. But like the grills like this, you have 4-way modulation. Here, when they commission it, they are able to do it like in both the ways, you know, horizontal and vertical distribution. So this is in the linear bar, the front is fixed, cannot be changed. The angle is 8 degrees. And this is what creates problem if you are smaller. So right type of grill can change the user comfort. You know, after a while, when somebody is sleeping in continuous that 2 meters per second of air is coming, it's uncomfortable.
سرعة الهواء اللي خارجة من الفتحة ما لها علاقة بسرعة الهواء اللي يكون متوزع بالغرفة. يعني سرعة الهواء بالغرفة عن مستوى العادية بيكون تقريبا نص متر بالثانية بحس الواحد براحته. بس بالفتحة بده تطلع 1 أو 2 متر بالثانية.
So here, what is important? So here, what is important, like why I put this one is when you have windows open season, and when you have mechanical cooling going on, and when you have reduced cooling season, you know, so all this, the air conditioning system should be able to give you the proper comfort. If you are working in off-peak season, not in summer, but you are in other season, that area also should feel as comfortable as it is in summer. It should not overcool. It should not produce higher velocities, higher airflows on that to give you that temperature very fast. So this is what defines. So earlier nobody was taking into that. So these are the new guidelines that is being added to look at the user comfort throughout the year. So you know, now calculating the fresh air, right, is formula, and you have to look at in the correct ways. The good news is there are some guidance already that you take so much per person or per square meter, right? So this is good if you want to do the practice on that, but there are ready-made guides that is available. And what I say, half of the people, you know, we all are bored of going into that detailed engineering, right? Sometimes we do it for a particular case study, just to, you know, check every boxes. But as we say, the technology is moving faster. So nowadays there is you know, a lot of tools available. There is this one particularly is a good tool. Let me I put it this one here. So if you have a phone, this is I put a QR code also. It's a free tool, calcengineer.com, and it has you put your airflow. It will show you, is it meeting the compliance, is it low, is it high. So it is as easy as that now. So you do not have to do a calculation level things that you do not want to do. So there are a lot of such calculators available. You might have your own you know, thumb rules and books on that. But normally if I am in doubt, this is what I am using it. It's very easy. If you have mobile, just scan the QR code. It will show you on that, and you can use it for your reference. Right? It's a very, very easy and a good tool to have it on that.
هي اللي حطها هو كان حساب تساعد بالفنتليشن للزملاء بالحساب كالكوليشن كل الفريش اير اللي حكى عليه صار فيها تعمل لها سكان تفتح لك بتحط انت البارامترات تطلع بتشوف النتيجه تبعتك بتوفر عليك عمليه الحسابات الموجوده بالفورمولا اللي قبل اللي حطها بالسلايد. تفضل.
So basically, this one in particular, do not look at number of people only. If you have bigger areas like lobbies, like corridors and all, where the square meter per square meter will preside, because that will show a higher value. You have to take higher of the two. So please make sure that you follow the correct one, which is either per square meter or per person, or whichever is on the higher side. Right? Then filtration quality, as we say, nowadays MERV 8 is a minimum requirement. So MERV 8 is a good way to follow. We were going G4 only up to now. So G4 is now replaced by MERV 8 filtration. MERV 12 or 13 if you want to achieve higher well class. But MERV 8 is something that is minimum recommended right now. And as we said, you go higher the number. MERV 13 is for a very good LEED buildings, is being followed. So this is something that you need to look at. Exhaust. So now once you have this sort of air, the distance also changes from the exhaust to the intake. So that also needs to be taken care of. You can do it in two ways. So let's say you want to say that I have complied with ASHRAE requirements, and you have to prove it. So when you have projects on LEED and other things, you have to prove your calculations, that you have done the right calculations. For that, you can go on either way. You can go on the prescriptive way, or you can go on the specific way. And you can come to the calculation on the both the ways, and it is acceptable. So make sure that you are familiar with calculating this flows in the right way, because this is what is required for the LEED one. You can generally say by following the principles, you can always get the compliance if it is not verified by third party. But if you are going for verified projects, then this is what is very important, that you follow the correct values on that. Yes. On the other side, basically, the U values also needs to be determined from the mechanical side. Like what U values you need for the roof and the wall, because this is what is important, because the compliance will come from the mechanical side, and this is where many times now civil also is defining the values, that this is what they will require minimum, and they generally go for a higher value. So this compliance of U values needs to come from our side on that. Glazing, single, double, triple, again, that is the same calculation for what is your heat gain per square meter, right? And if it is glass and the heat gain is higher, you need to change the glazing to the next level. So this is something that you need to look at it for sure on those ones. These are some of the tables that I created for kitchen, bathroom and toilets. Like if you have a continuous demand or if you have an intermittent demand, what is the difference between the two? That means you have an exhaust fan. Continuous means you have a central exhaust system for the whole house, and continuously that fan is working. Or you have individual fans in individual toilets or kitchen. So kitchen, whenever you are using it, then there are different ones. Like if it is a intermittent one, means you have mechanical switch in your kitchen for exhaust, it's 100 CFM on the vertical hood, or 300 CFM if the hood is recirculating type. So many times we use hood that is recirculating. There it will require more on that. If you're continuous, definitely your size is less, but this is 24-hour operation. That is the difference between the two on those ones. So this is where you can take any of the local exhaust systems as well. Air tightness definitely is.
يعني بالنسبة لموضوع التهوية في عندنا طريقتين، إما تهوية مستمرة أو تهوية متقطعة. عادة لما بتكون التهوية مستمرة بتكون تجهيزات حجمها أصغر من التجهيزات، بالحالة التهوية المتقطعة بتكون التجهيزات أكبر. هي الستاندرات تبعاتها وهي البارامترز اللي لازم نعتمدها أثناء عملية التصميم.
حاطين لكم كل شيء، مطابخ، الحمامات، كل هذا حاطين كيف الصوت عليه اذا كانت تهوية مستمرة او لا.
And definitely this is mostly on the civil side, but we need to look at it and tell about the air tightness. If the building is not airtight, the ventilation will not be proper. So this is something that is there on the civil side. They need to do it on those sides. Otherwise, MORB 8 and MORB 13, if you look at that rule, you should be fine. Humidity condition, as we said, is between 30 to 60% RH, right? So this is something that needs to be looked at as well on how to control the humidity. On if the air is transferred from one side to the other side. So if from one room to the other room, like this is mainly in terms of kitchen and toilet sites, if the movement of the air is not enough, then it can have a mild microbial growth. So this is also important, and what air transfers can be done. But generally, if we have negative, kitchen and exhaust, it should not be a big problem on that. If it is a central building and you are going for fresh air handling units or all air systems, then you need to be careful on the distribution and continuous processing of it, because if you want to take the return air and do heat recovery, then the coil load changes, but you need the infrastructure in the building to run two shafts of supply and exhaust. If you are just exhausting, the cost will be high. So direct systems may be looked at in a different way. Sometimes you can just have the fresh air in the corridor, and then each unit is taking it from the corridor. So you have different schemes that you can reduce the fresh air also. This is the highest cost. Any building, if you are doing, and if you have to put a fresh air system, 30 to 40% of the cost is of running of the fresh air and the fresh air system. So this is where very important is to look at. There is new standards 241 and other things which is allowing the recirculation also. So these are the things that you look at when you're doing a residential building. But if you are doing a normal one, you should be okay with a standard trade-off on that. If it's a lead building, then they may ask for extra conditions like recovery and other things. So if you are looking for lead or net zero, so if you are looking for very high things, the calculation will be endless. So this is what the guidance are there. So this is also, if you are a lead AP, well, go for that certification. ASHRAE is offering certification in studies. You are certified? Anyone is certified on lead or?
هو الاستاذ كتبنا الحاضرين الكرام اخذ شهاده الليد سيرتيفايد من الليد.
But if you know it, then when your design comes out, it comes good. So this is where it is important on the.
يعني انا بضخ هواء وبسحب لو المطبخ على طول في عندي سحب بدي الضغط انا بدي احافظ على الضغوط، يعني انا بدي احافظ على ضغط
الافضل يكون الضغط ايجابي جوا حتى ما يدخل الغبار.
يعني انا كميه الهواء اللي بسحبها نفسها بدي الضغط.
والافضل اعلى تكون الضغط.
اعلى.
يعني يضل الضغط الداخلي بوزيتيف موجب.
So basically this is what it is on ashtray. So basically 55.
Maybe we can have a break and then after the break quickly we can talk about.
تاخذ استراحه 10 دقائق ساعه.